Good evening, my 12th standard warriors. Welcome to the session of Electrostatics with me, Shreyas, your physics master teacher at Vedantu, going live. And today we are going to have a revision session, a backlog clearing session of electrostatics. So let's get started, guys. How is the Josh? How are you? Long time no see. Hi Surya, Janish, Dinarthana. Hello Swati, welcome aboard. Welcome. Yes, a lot of you have been waiting for this session for a very long time. So nice to see all of you guys. Good evening, Alone Gamer. Hi Surya, hi Harni. Welcome aboard. Welcome everyone. Okay, so let's get started. Just 1 second. There's some network issue out here. Yeah, just short. Yeah. All right. Okay, fine. Hi Shailendra. Hi Lime. Hi Arul. Hi Uncharted. Good evening. So I hope you have attended, the session of clearing backlog and how to target, the top all India ranks in the next year, that's JEE 2022. Now this is a part of the Pathfinder series, which is a long-term series for all the 12th standard students. So, if you have not watched that backlog clearing session and the strategy session on how to ace and how to score really well for the next year, I would, request all of you, all the viewers, even if you are watching it recorded, please watch it. You can easily find it on our channel itself. Just search for it. All right, JEE 2022 strategy by Shreyas sir, you will get it. Okay. So yes, even if you are a NEET student, yes, definitely you can attend it. And also, am I going to start Nurture series? Prashant N, I have already started Nurture series, Bachalo. So Nurture series was started long time back. So Nurture series will in fact continue from wherever we have left. And also you're going to see a lot of backlog covering sessions even in Nurture series tomorrow as well. We are going to have a backlog clearing session on kinematics one day tomorrow for 11th standard students. Even 12th standard students can attend it. So if you go down in the playlist of our channel, this is where you're going to see the JEE physics playlist, and you are going to see all the 11th standard course playlists out here: units and dimensions, vectors, 1D kinematics, etc. And the 12th standard playlists are also over here, like current electricity, capacitors, Gauss's law, electrostatics, and all of that, magnetism, EMI. We're going to do AC circuits next after EMI. Hold on. All right. So let's get going. And if you are new to the channel, do not forget to hit the subscribe button, because it means a lot that, you are showing your continued support and you want to see all our lectures live or at least in the recorded form whenever you get time. So do not forget to hit the subscribe button, and also do one favor. Please smash that like button out there. So shall we get going, guys? Yep. So go in then after some time. So just give us a week, and probably after a week I'll start AC circuits also. All right. Chitra is going to miss you. Yeah, Chitra, we are going to miss all the 2021 students, but you guys are free to come anytime. And don't worry, we are going to be there with you guys for few more weeks till your counseling happens. Okay, don't worry. All right. So let's get going. Yeah, Siva, this Saturday I'm coming on Biotonic for a formula revision session. Saturday morning, 9 o'clock. So probably Vani ma'am would have announced or will announce it very soon. But yes, Saturday morning I'm coming on Biotonic. All right. So this is a schedule for this week. Tomorrow, like I said, one short revision session for the 11th standard students, and one more revision session for you guys on Gauss's law. So guys, do you want the Gauss's law revision also to be done? Well, that's coming up on Saturday for all of you. Okay, we'll slowly revise all the chapters in one shot. All right, so let's get moving. But before that, let me also congratulate all the board toppers from Vedantu, be it ICSE, be it CBSE, be it State Board, be it JEE Mains 1, 2, 3. Doesn't matter, our students are there everywhere, and they have shown continuous improvement right from JEE Mains 1, second attempt and the third attempt. There is almost like 7.5x improvement in the number of students above a particular percentile, and there are 700 students just above 99 percentile, and more, almost like 3000 students above 90 percentile. And all of this is because of the platform that we give you with assignments, tests, master teachers, doubts, recordings, live classes, the booklets, everything, the whole ecosystem, the parent-teacher sessions, the strategy sessions, all of this in our Vedantu subscription. And if you are a 12th standard student, do not forget to check out the link which is there in the description box below, because the batch is going to start this Monday. Enroll yourself now because the seats will fill up, and if the seats fill up, then you will be enrolled in the next batch. You get to choose between the teachers as well in case you are not happy with the current set. Yes, that's freedom is there. Also, let me tell you, the batches are going to be in English, so you don't have to worry about, oh, is it going to be English? No, there are English batches separately and there are Hindi batches also separate. So don't worry, check out the link and use my coupon code to get that 10% off. So let's start with properties of charges and then the problems on that. So the way I have divided this class is there is theory and there are problems. Theory, problems, theory, problems. So we are going to revise this in one shot. Get set, go guys, time has started. Okay, so first of all, see, electrical charge is nothing but a property which is, it is a characteristic of any object, and there are three kinds of charges. One is positive, negative, and the third one, actually it's a neutral, no charge. So neutrons have no charge, electrons have negative charge, positive charges are there with protons. Now like charges repel, opposite charges attract, and these charges are scalars. That means you don't have to worry about the direction. Charges are scalar quantities. That's why you can just add or subtract these charges. That's what you need to keep in mind. Although charges have signs, plus and minus, does not mean it has direction. A lot of people have that misconception that, oh, if something has plus and minus, then probably it is a vector quantity. No, something can have sign, but it might still be a scalar, and charges are the best example of that. You can just add and subtract charges without having to think what direction are they in, because there is no meaning of any direction for the charges. Not just that, charges are also conserved. So for a closed system, the total charge is conserved. What it means is that, imagine this, if you have a system, okay, let's say this is a neutral body, this is right now neutral. Now if you let's say for example, if you take away few electrons out of this, if you take away, let's say 3 electrons out of it, 3 electrons have been taken out, you will immediately see 3 positive charges will be developed on this body. Now these negative charges might come out. You might see that, oh, there are positive charges which have been created. But also understand, 3 new negative charges have also come out over here. The total charge of the complete system is still 0. So a new charge, alright, new net charge can never be created or be destroyed. That's what the law of conservation of charges is. So you might have new charge being created, but the total charge will always remain same for a closed system. Is that clear, everyone? Is that clear? Rohan, there is nothing like weightage of this chapter in JEE. This chapter is important, and since you are a 12th standard student, please do not attend those strategy sessions which tell you what is the weightage of a chapter, especially if you are a 11th or a 12th standard student who is going to write the examination next year or next to next year. If you think of the weightage, then for sure you are going to neglect few chapters, and that will cost you a lot of marks in the final examination. See, if you are going to write the examination now, then it makes sense to talk about weightages and probabilities. But still, there is nothing like weightage, because NTA does not give any weightage of chapters like board examinations does. Okay. Now, having said that, there is also one more thing, and the charge is quantized. Quantization means charge can be only in multiples of this number. This number is the charge on an electron, or magnitude of it. So 1.6 into 10 to the power minus 19 is the charge of an electron or a proton. So you can never have a charge of 2 into 10 to the power minus 19 Coulomb. This is not possible, because it is not a multiple of 1.6 into 10 to the power minus 19. So all charges which are integral multiples of this E, which is 1.6 into 10 to the power minus 19, are only allowed. Anything else will not be allowed. Charges are only in these discrete numbers. They cannot be any intermediate values. Is that fine? Is that fine? Alright. Yes, Vikram, there is lots of time to study. That's why you don't need weightages. Correcto. Let's get going with some questions coming up on your screen. Everybody knows the unit of charge is Coulomb. By the way, is this a fundamental unit? Yes or no? Let me know in the chat box. Thank you, sir. Is Coulomb a fundamental unit or a derived unit? Let me know in the chat box. Is it a fundamental dimension? Is it a fundamental unit or is it not a fundamental unit? Let's see how many of you get this. Very basic question. A lot of people make mistake over here. Is it a fundamental unit or is it a derived unit? Come on, my warriors. Let me know in the chat box. What do you guys say? Yes. Ram Kailash says derived. Jani says not fundamental, not fundamental. Very good, very good. Pramesh, don't worry, bacha. We'll have counseling also for all the outgoing students. Yes, amperes is the fundamental unit. Ampere into time is 1 coulomb. Ampere into second. Ampere second is 1 coulomb. Ampere is the fundamental unit. Seconds is the fundamental unit. And coulomb is a derived unit from amperes and seconds. Keep this in mind. Okay, a body has a charge of 9.6 into 10 to the power minus 19 coulomb. Is it possible? Not possible? May or may not be possible? Data is not sufficient. Come on, my warriors, let me know in the chat box. What do you guys say? Archana, I'm very good, bacha. Thank you. Yep, Harish, very good. Very good, Kashish. Very good, Swalina. Very good, Indutua Khaj. Janish, very good, Vijay. Very good, Shruti. Joker, Jayant. Yep. Jahir, I'm very good, bacha. I hope you guys are doing well. Yes, some of you are saying it is possible. Well, Surya, be careful. I feel it is not possible, and the reason for that is look at this value. 10 to the power minus 19 or minus 20. 9.6 into 10 to the power minus 20 is not an integral multiple of 1.6 into 10 to the power minus 19. In fact, this number over here is smaller. This is smaller. This is smaller than E. How can this be a multiple of E? See, if you have, let's say for example, E is equal to, for example, 3. How can a number like 1.2 be some integer into 3? Obviously, when you multiply with an integer, that number will be more than 3, right? So I hope you understand this number is smaller, so it can never be an integral multiple. So this is not possible. Very good. Some of you got it correct. Excelente. This was an easy one. Let's see how many of you get the next one coming up on your screen right now. A polythene piece rubbed with wool is found to have negative charge of 4 into 10 to the power minus 19 coulomb. The number of electrons transferred from the wool to the polythene is, let's see how many of you get it. Very good, Surya, you got it finally. Okay. Bal Subramaniam, how do you get courses in English? So when you enroll, you're automatically enrolled in an English batch, and let's say some students want Hindi batch. All right, you just have to mail to VCare. In fact, when you join, after a few days you get a call or an SMS saying which batch you would like to join, so English or Hindi. So by default you are put in an English batch, but if you have that preference of Hindi batch, then you are put in the Hindi batch. So you don't have to select anything, it's automatically done, don't worry. And if still you are put in a wrong batch, don't worry, there is a simple email ID, or you can get in touch or leave a comment over here. I'll solve that. Okay, cool. Yes, we will have NLM also in one shot, bacha, in sequence, 1D, 2D, all right, all these things, and then we'll come to NLM. So you'll get the DPPs, Muhammad Arsh. In Vedantu, there are assignments. When you join the pro subscription, there is a link. So you'll get assignments session wise as well as chapter wise. Okay, a lot of you are getting B and C. Well, the correct answer is actually C, guys. Many of you probably made a mistake. Some of you said A and some of you also said B. Guys, the answer is C. Understand this number, coulomb, how much is it? 4 into 10 to the power minus 7 is some number times of E. This E is nothing but 1.6 into 10 to the power minus 19. Some of you might argue it's a negative charge. Well, this is negative, then this is also negative. Then the minus sign will cancel on both sides. So you really don't have to worry about it. So N will be 4 into 10 to the power minus 7 divided by 1.6 into 10 to the power minus 19. Now you can do the math. So this is 4 and this is nothing but 0.4. So take it on the top and you are going to see this as 1 by 0.4 into 10 to the power minus 7 and 10 to the power 19. All right, is that correct? Yep. So this will be 10 to the power 19 minus 7, which is going to give you this 1 by 0.4, guys. So it is going to be 2.5, and 19 minus 7, that's going to be 12. Yep. Yep, very good. Did you guys get it now? Everybody clear about this? Shall we go ahead? Somebody made a power mistake. Thank you, Gangarupu, for all the love, bacha log. All right, Manpreet Rana. Okay, chalo, let's get going. Let's get going. Okay, coming up on your screen now, next question. You're going to see all the concepts covered today from electrostatics. We are going to have Gauss law as a separate backlog one-shot session. It's humanly impossible to do Gauss's law and electrostatics as one-shot revision, in one class. All right, so let's do this. The identical metallic spheres A, B, C are initially neutral. A is given some charge. A is touched to B, then B is touched to C, and then C is touched to A separately. What is the final charge on C? Interesting question. Archana says clearo. Srija also clearo. Very good, Swarlina. Thank you, Faiz Mohammed. All right, come on, guys. Thank you, Gangarapu Vasanta. Okay, Ankit is getting A. Interesting. Faiz, thank you, Bacha, for all the love from Kerala. Thank you, guys. You guys are showing tremendous love and your support right from Jammu Kashmir, right from Assam, right from Nepal, Sri Lanka, Tamil Nadu, Gujarat, Maharashtra. Thank you, guys. Okay. Okay, so I'm very good, Shweta. A lot of centuries. Yep. So I'm very good. I'm very good. I have still not grown very old, I guess. Okay. So Yuval Singh, please watch the lecture which I have conducted for JEE 2022. Yuval Singh. Okay. Just search on my channel, on this channel, JEE 2022 Shreyas Sir. All right. Strategy. You will see the detailed plan how to clear backlogs and how to study even if you have not done anything. I have given all the chapters which needs to be studied. That's something which you can do, I'm pretty sure. All right. Okay. A lot of you are getting D, some of you are saying A, some of you are saying B also. I'm pretty sure many of you are confused over here. So a lot of confused heads. Let's see how to do this. So let's me write down A, B and C over here. And let me see what are the charges initially. Initially this had Q. This will be 0. This will be 0. When you touch A and B, the charges will get distributed equally because they are identical spheres, so they will get distributed. So metals means they will be conducting, so they will share the charge. So this will have Q by 2, this will also have Q by 2. C is not yet touched. Next step, you touch these two, this will remain unaffected, so this is Q by 2. Now this Q by 2 will spread in both of them, so half of that is Q by 4 and this is also Q by 4. Notice every time if you do the total, it should always remain as Q because total charge has to be conserved. Last time C and A are connected. Now this will remain Q by 4, of course. The total charge has to remain Q. So how much charge is remaining? 3Q by 4. 3Q by 4 divided in both of them. So it will be 3Q by 8 and this will be also 3Q by 8. That is the answer. Yes, the answer is D, guys. Very good. Some of you made a mistake. Probably you should understand now where you guys made a mistake. The correct answer is 3Q by 8. Did you guys get it? Understood or clear? Shall we go ahead? Let me know in the chat box. Yes, the answer is D. Very good. Yes, Abhinav, but that's for CBSE. For JEE, there is nothing like marking scheme or weightage and all of that. Hai na? So, all right, no problem. Some of you made some silly mistake. Okay, so even 11th standard people are watching this. So all the best, but don't worry, we have 11th standard classes which are called as nurture classes. What is Pathfinder? Pathfinder is 12th standard classes, guys. Okay, so the 12th standard classes are called Pathfinder. Do you know how many chapters I have completed? Probably all the old warriors should tell the new warriors. Riya, remember you, bacha. Very good. So basically, I have completed electrostatics, Gauss's law, current electricity, magnetism, bar magnetism, magnetic properties, electromagnetic induction. And I was about to start AC, but then a lot of students said, please clear the backlog. So I'm doing that. And then I will start AC and then ray optics and all of that. Don't worry, guys. I'm still there with you. Okay. Thank you, Susmita, for calling me Thalaiva. It means a lot. Coming up with the next pointers. The force between two charges, which is the Coulomb's force, is given by K, Q1, Q2 by R square. Very similar to your gravitational law, G M1, M2 by R square. This K is called as the Coulomb's constant. So Coulomb's constant is 9 into 10 to the power 9. Some people also write this as 1 upon 4 pi epsilon naught. This is called as the permittivity of free space. Now, what exactly this is? This is going to tell you how permissible are the electric field lines in a given medium. In vacuum, if there are two charges, they will exert some force. But the same two charges in some other medium, you will see their net force will change. Their effective force between the charges will change because the medium has some property called as dielectric constant. We'll be discussing or we'll be taking some problems on that in Gauss's law or in capacitors. But for now, just remember that permittivity is a property of a medium. Vacuum's permittivity is epsilon naught, and 1 by 4 epsilon naught is 9 into 10 to the power 9. If the medium changes, then you will not write it as epsilon naught, you will just write it as epsilon. Epsilon is the permittivity of that particular medium, which will decide how much electric force will be there between those two bodies. Okay, now also remember this force follows superposition principle. Now the meaning of superposition principle is that, let's say there are two charges and this charge is pulled by this charge or attracted or repelled, it could be anything. So let's say that is the force acting on 1 by 2. Now if I place another charge, let's say Q3, then this Q3 might also apply another force. So let's say it is force on 1 by 3. Now this force by 3 on 1 does not depend on charge 2. Obviously, that is a matter between these two people, these two gentlemen. So the force by 3 on 1 depends on only Q1, Q3 and the distance. The force by 2 on 1 only depends between these two, not on this. Hence, the total force on 1 will be the vector addition. So it will be F12 plus F13. This will be the net force acting on 1. Is it fine? Shall we go ahead? Harish Duraj 1980. Somebody is asking, sir, should we just watch one-shot videos? And can we will we understand all the concepts? What do you think, guys? Honestly, ask your heart and tell me. A lot of YouTubers will claim, just watch my one-shot video and everything will be done. I am not going to say that. In fact, I will say one-shot videos are essential. One shot is essential to get a head start. It's very, very essential to get a head start and overview of that chapter. It will give you a push. Okay, apart from that head start and that overview, it will give you a push. Okay, it will help you cover the backlog till, easy or medium level. Okay, I'll just put it to medium level or easy level. But you need to push yourself ahead. So you need to watch the detailed classes, long-term classes. Only then you can improve, and you can improve to advanced level and even mains level. Okay, so just watching one shot, please don't misunderstand and think that, okay, I will get everything. But if you probably start here, it will take a long time. So that's why we do one shot, because you can get that head start, that push, covering up your backlogs, and you will get that momentum. And once you have that momentum and you have the fair idea of the chapter, then you can watch all the detailed classes and then you'll be like, now I'm understanding. So that's the reason for that. You can do it really quick. Okay, chalo. Let's get going with some questions, guys. Okay, and here are the questions coming up on your screen. Yep, correct. We also said that. So Vasanta, my timings of the classes are usually 7:30, but because these are big classes, so I started at 6:30. Yes, you will sing. You should definitely join Vedantu Pro. I'm coming up with nice classes for you guys this month. You are going to see that, and you can watch my micro courses as well. Yup, perfect combination, Faz Mohammed. You said it. Pathfinder, one shot, Setsi Verma, and also previous year question papers and Tattva module also. I'll add to that, Faz. Okay. Yes, Ram Lakshman, PN. Okay. So guys, come on, let me know. PSK, I'll tell you more details about the advanced crash course very soon. Just hold on, just hang in there, okay? So what about this, guys? 2 point charges repel each other with a force of 100 Newton. One of the charges is increased by 10% by transferring it from the other charge. what is the force of repulsion for the same distance? Interesting question, guys. Come on, my warriors, let me know in the chat box. What do you guys say? What the answer should be? Okay, come on. Let's do this. So earlier, the charges were Q and Q, for example. Okay, 2 point charges repel each other. I think 2 equal should be mentioned. Okay, equal point charges. Okay, that was missing, I guess. Okay, so the force between them, they were repelling each other. So 100, and this was also 100 Newton. So that force will be kq square by r square. Now what you're doing, you're taking 10% of the charge from one and transferring it to the other. So if you take 10% of the charge, that means 0.1, 1/10. So if you take 1/10 from here and put it here, this will become 1.1 q and this will become 0.9 q. So what will be the new force is the question. So that new force will be K 1.1 q into 0.9 q divided by r square. But wait a minute, I can see from here I have kq square by r square and into 1.1 into 0.9. This quantity over here is already known to me and this was already given to be 100 Newton. So this quantity is nothing but 100. And what is this, guys? This 1.1 into 0.9, that's 0.99. So that means it should be 99 Newton. How many of you got it? Okay, many of you are seeing B, many of you said C, Janish said D. Very good. Some of you only got it correct. All those students who said C are correct. Nitya Bacha, I know I'll do 11th also. So tomorrow is the 11th standard class, okay? Just check my timetable. I gave it at the start. So tomorrow you are going to have your backlog series for 11th standard kinematics 1D, and also we'll continue slowly with the next chapters as well. All right. So see you tomorrow as well. Good evening, Shivam Kumar. All right, let's get moving to the next question coming up on your screen. That was 99 Newton. Many of you made a mistake, but I hope you got it now. Very good, Shruti. Excellent day. Now, tomorrow 1D kinematics in nurture backlog covering session. Very interesting question. Many of you will make a mistake. So be careful. Read the question carefully. In the figure, two positive charges Q2 and Q3 are fixed on the y-axis. They exert a net electric force in the x direction on charge Q1 fixed along the x-axis. Now, if a positive charge Q is added at x, 0, you can see that a positive charge Q is added at x, 0, then what will happen to the force on this charge Q1? Then the force on the charge Q1 will increase, decrease. Where will it decrease? It will point on some other direction. What will happen? 4 options are given. Let's see how many of you can get this. Hi Kunj Nathanai, welcome aboard. Very good, Ria, it's clear now. Hi Shashank Singh, welcome. Bhargav, too many coffee sessions will probably, keep me probably, a lot of, what do you say, that sudden rush, too much of caffeine in my body, and probably I will not sleep only then. Too much of coffee is not good for health. So let's probably do these regular sessions. Soon I'll come up, hold on. I'm very held up because there is NEET exam coming up. There is JEE Advanced exam coming up. Plus I have the 11th standard kids to take care of. Plus I have the 12th standard kids to take care of. Not just on YouTube, but also on my regular paid classes. Yeah, chalo, let's get moving. Okay, a lot of you are saying A. Very good. Oops, yes, the answer is A. Yup, very good, very good. The answer is A, and the reason for that is Q2 and Q3 together apply a force in the plus x direction. Now both Q2 and Q3 were positive. The only way they can apply a force this way is if Q1 is negative. How? This negative charge will be attracted by these two, and hence the net force will be in this direction. Now over here, if you add one more positive charge, then on this negative charge, apart from this force, there will be one more force in that direction. So what will happen, guys? That force will increase. So it will increase along the positive x direction, which makes sense. Very good. Excellent. Correcto. Let's get moving ahead. The ratio of electric and gravitational force between two electrons is interesting. Let's see how many of you can post the answers before I complete the question. Ratio of the electric and gravitational force between two electrons is? Distance is not given. I don't know. Just write the answer in terms of variables. Let's see how many of you can give the answer very quickly in the chat box right away. So the force of gravity and electrostatics between two electrons is in the ratio of, so force of electrostatic upon force of gravity. Now electrostatic force is 1 upon 4 pi epsilon naught, okay, charge into charge divided by r square. Similarly, the force of gravity is G m1 m2 divided by r square. R got cancelled and there we have E square by 4 pi epsilon naught G m square. That's the answer. Very good. Excellent. Now, if I tell you which one will be more, okay, I'm not interested in the final answer, okay, like the value, just the variables. Okay, very good. This is very interesting. This is the answer and this is a constant value because it does not depend on R. Now once you get this value, the interesting thing to note is that, you know, the power of Q is approximately, I'm not saying exact value, just think about the power. The power of Q is 10 to the power minus 19. So this is 10 to the power minus 19 square, and 4 pi epsilon naught, 1 upon 4 pi epsilon naught is 10 to the power 9. 1 upon 4 pi epsilon naught is approximately 10 to the power 9. G, okay, 10 to the power minus 11. So when you put it over here, this is 10 to the power minus 11. Mass of an electron is almost 10 to the power minus 31. So 10 to the power minus 31 and whole square. What do you think, guys? This number will be very small or very huge? This number will be very small or very huge? Come on. Last step, I just cancelled r square and r square, Surya, that's all. I just cancelled r square and r square, and you know, electric force is k q1 q2 by r square, gravity is g m1 m2 by r square. So r square gets cancelled and I just put k as 1 pi 4 pi epsilon naught. Is it? How q2 came? Oh, this is not q2, this is q square. Think of this q square as e square. The charge itself is e. Okay, cool. So is it going to be very small or very huge? Guys, this number will be very huge. Look at this. 10 to the power minus 19, this is 10 to the power minus 31. When it goes on the top, and this 10 to the power 9, and this 10 to the power minus 11 going on the top, becoming 10 to the power plus 11, this is going to be a very huge number. What it means is that the electrostatic force is much larger than the gravitational force. Is that making sense? So you will see the statement in many of the books, electric force is a stronger force than gravitational force. Gravity is weak force. This is the reason for this. Did you guys now understand it? Did you guys now understand it? Clear? Everyone, shall we go ahead to the next question coming up on your screen? Okay, chalo, let's get moving, guys. Okay, chalo. Here is the next question. 5-point charges are placed, plus minus are placed at the 5 vertices of a regular hexagon of side L as shown. What is the magnitude of the force on a point charge of value minus q? This is the charge which is placed at the center of the hexagon. Very interesting question. Let's see how many of you can do this. These kind of questions were very popular in JEE mains examination, even in this particular attempt, even in the 4th attempt, even in the 3rd attempt. There were many questions which came from vector addition and forces of electrostatics. Let's see how many of you can do this. Now, first of all, you should realize few things. What are those few things? This positive charge and this negative charge will attract each other. So let's say I call it F. Same negative charge and positive charge will again attract each other. Now that will be also F. Reason? Magnitudes, distances, same. So shouldn't these two forces cancel each other? Shouldn't these two forces cancel each other? They are directed opposite and same in magnitude. Now similarly, this negative and this negative will repel. So the force on this will be this way and obviously this way. So these two forces are also going to be F and F. So hence these two will also cancel each other, opposite and same in magnitude. The only thing remaining is this, and obviously what will be there between them? Attraction. So this negative charge will be attracted, and hence the net force is just going to be F, and the value of that force will be K Q1 Q2 by distance. Now remember one thing, in a hexagon, if this is L, these are all equilateral triangles, so all the sides become L, including the inner diagonal's half length. So all are L, so this will become just, nothing but L square. So you can just put it as 1 upon 4 pi epsilon naught Q square divided by L square. Very good, excellent. So it will be in the horizontal direction and towards the right side. So if somebody had asked what is the net force vector, I'll probably put I cap because it is in the x direction. But if they are asking only the magnitude of the force, then only you will give this particular value, which is over here. Okay, so this much is only the magnitude. Okay, this is the magnitude. Everybody clear? Can we go ahead to the next concept coming up on your screen? Very good, excellent. Many of you have got it. Excellent, warriors. Yeah, you can see that as the answer. Now, before we go ahead, let me also quickly showcase one small thing to you, and that is the Tattva booklet. Guys, if you want to practice all kinds of questions, see what we are doing right now. Concept problem, it becomes easy to understand. The same thing is there in the Tattva book. Let's say electrostatic force, you will have an exercise, okay, topic named electrostatic force, only questions on that. And then electric field, only questions on that. Then electric field lines and potential, only questions on that. That will give you additional boost, and confidence of, all the concepts in physics, maths, chemistry, whatever it is. Number one. Number two, there is level 2 questions where you can get a good level of questions for JEE mains and even previous year questions. And then there is advanced level questions. And then finally you have previous year advanced questions. And not just that, the entire summary, formulas, theory for that chapter, important points for, quick revision. That's Tattva book. You get it as a part of the pro subscription. So if you are a pro student, you will get it, and you need to join for 1 year. Even if you are paying EMI, that's okay. So that's about the Tattva book, which you should know. If you join crash course, no. Swati, all the crash course students cannot cover, all these books. Look at the size of this book. This is just one topic, right? Now imagine so many books will be there. So it's impossible to cover this book within 1 month. So that's why you will get this only in a long-term batch. Okay. Chalo, let's get moving to the next one, potential energy. Whenever you have two charges, they also have something called as the electrical potential energy, and the formula for that is K Q1 Q2 divided by R. Notice there is no R square over here. There is no R square. Okay, it's just R. Now, if the two charges are positive or both the charges are negative, in that cases the potential energy is also positive. But in a particular case, when one of the charge is positive, other charge is negative, in that case potential energy is negative. Reason? You can check the product. If plus into plus, plus, plus into minus, minus, minus into minus, also plus. So potential energy depends on the nature of the charges. Not just that, you will see with change in the distance, the potential energy will also change. It's very obvious. It depends on the distance R between them. Correct? Now, not just that, guys. Remember one more thing. The unit of potential energy, okay, obviously it is joules, and sometimes you might be asked to find the potential energy of not just two charges, but maybe multiple charges. Q1, Q2, Q3, maybe even Q4 is there. And if you are asked what is the total potential energy of the system, you have to find potential energy between every 2 point charges. Meaning, first find potential energy between 1 and 2, then find potential energy between 1 and 3, then find potential energy between 3 and 4, then find potential energy between 4 and 2, and then find potential energy between 2 and 3, and then find potential energy between 1 and 4. So how many terms will you get if there are 4 charges? How many terms will you get? Let me know, guys. Where do we get Tattva book? Vasanta, when you join the pro subscription, then you automatically get the Tattva book. It will be couriered to you. So you enter your address and all of that, right? When you join Vedantu. So it will be couriered to you, and you will also get all the hard copies depending on which standard you are. Yes, there will be 6 terms. 1, 2, 3, 4, 5 and 6. In general, if there are n charges, for n charges, how many terms will you get? Quickly let me know in the chat box. Let's see if you are very good at math out here. Swati, it won't be 8, bacha, be careful. If there are n charges, how many terms are you supposed to get for the potential energy? Let's see how many of you are good at math. Very good, Salvakumar Karthik has answered it very quickly. It will be NC2. Excellente. Excellente. It will be NC2. It's just like saying I have n points and I'm choosing every 2 points in pairs. So there are n points and I'm choosing 2 at a time. So I'm choosing 2 at a time. So NC2. Excellente. Yep, very good. N into n minus 1 by 2 is also fine. It's the same as NC2. Okay, very good. Excellent. So for a system of charges, I mean, this formula might look confusing. It's just that you have to take all of them in pairs. Let's start doing some questions based on this. Okay, Manisha, I'll answer your question. Come on, all my rest of the warriors, start solving this question. A charge of 5 microcoulomb is placed at a point. How much is the work done to take this charge in a quarter of a circle? So, where can you cover modern physics till advanced level theory sums and also suggest some important topics for advanced 2021? So for modern physics till advanced level with theory and problems and the topics. So Manisha, you have to do all the 4 topics obviously, like nuclear physics, X-rays, atomic structure, photoelectric effect, wave particle duality, photons and all of that, and atomic collisions. All these are important things. Now if you have not done H.C. Verma, I would say first do complete H.C. Verma exercise questions, objective 1 and 2 and all of that. Second thing, please do previous year questions, okay? And then if that is also done, then please check out, we are going to, if you are having a percentile more than 97, then you can, probably you should be a part of Eklavya, but if you are not a part of Eklavya, then we are going to give you some material over here for solving. Okay, so on this channel itself, we are going to give you some material for solving. And if you still don't, if you have not joined any coaching, then I would say you can go for probably DC Pandey. Okay, at most DC Pandey you can go, but that is if you have not joined any coaching and you don't have the coaching material. Okay, chalo, let's get going. A lot of you, come on, my warriors, let me know what's the final answer. A charge of 5 microcoulomb is placed at a point in a quarter of a circle of radius 7 centimeters. I think this should not be difficult. This is 5 microcoulomb charge, and you are taking another charge in a semicircle, quarter circle of radius 7 centimeter. Well, this is 1 coulomb charge. Between them, there will be a force. The force will be like this. Now the force is like this, and this is the displacement. Guys, isn't it obvious the work done will be 0? It will be 0. It will be 0. Yeah. What are you breaking your head for? Okay, you don't have to calculate the path length and anything else. It's just 0 joules. How many of you got tricked in this? Such an easy question, alright? Chalo, no problem. Let's get moving to the next question. A charge of 5 microcoulomb is, okay, this is done. Next question, 3-point charges plus Q, minus Q and plus Q are placed at the vertices of an equilateral triangle of side A. What is the work done to double its side? Very interesting question. Okay, lovely question, says Dhanush. Zahir says anda. Yes, anda. Ande ka fanda. Let's get moving to the next question. What will be the work done to double its side? Why will be work done? Probably it has energy. So to change the energy, I need to do work. Okay, come on. A lot of you are thinking too much. So first, probably we should draw the diagram and then we will get some idea. Okay, this is my triangle, this is side A, this is also side A, this is also side A, and we have point charges plus Q, minus Q and plus Q. What would be the initial potential energy? Potential energy between these two will be K minus Q into plus Q, that will be minus Q square divided by A. Then between these two, it will be plus K Q square by A. Between these two, it will be minus K Q square by A. Very interesting part, these two get cancelled and I'm just left with minus K Q square by A. That's the initial potential energy. Now, if you increase the side, you double it. Let's say you double the side. So instead of A, you will just have 2A. So the final potential energy will be minus K Q square by 2A. Now the last part. The work by you will go completely in increasing or changing the potential energy. Let's say you are holding a block or some object. Okay, you will lift it. So your work goes in changing the potential energy. So to change the side, you have changed the potential energy. Think that way. So this will be nothing but final minus initial. So what is final? It is nothing but minus KQ square by 2A. What is initial? Initial is minus KQ square by just A. Minus minus plus. So you are going to get KQ square by 2A with positive sign or negative sign. Come on guys, this is 1 minus half, so it will be plus. So the answer to this question should be D, right? Yep. Shouldn't it be D? Understood? A lot of you probably would have thought the answer is A. No, the answer is not A, nor is it negative. It is plus KQ square by 2A. The change in the potential energy is given by the work done by the external force. Keep this in mind. Okay. Now, I have one small, additional problem over here. And this is where, J is going to test you. Mind it. Now, here is my question. If the question was not the work done by the external to double the force, but instead, what is the work done by the electric forces themselves? What is the work done by the electric forces themselves? Then the answer will be exactly negative of that. Remember one thing, work done by a conservative force is minus delta U. Therefore, if they had asked you what is the work done by the electric force, then it will be minus of UF minus UI. So it will be exactly negative of this. This is something which you should know. Remember, when I'll give you an example, you will never forget it. Okay, just tell me this guys, if I increase the height of this pen, let's say the potential energy increased by 10 joules plus 10. Everybody understanding this? Let's say I take this pen higher, I increase the potential energy by how many joules? Plus 10 joules. Now tell me, how much work did I do, which is an external force? Work done by external. Is it plus 10 or minus 10? Think about it and let me know. How much work did I do? I took this pen on the top. Did I do plus 10 joules or did I do minus 10 joules? Come on, help me out. Did my force on the pen do plus 10 joules work or did it do minus 10 joules of work? Come on my warriors, this is very simple. Selva Karthik saying minus 10. Interesting. Come on my warriors, think. Use your brains. Come on, activate yourself. Okay, Riya is saying minus 10. Okay, Vasanta saying plus 10. Some of you are saying minus, some of you are saying plus. The answer is plus 10. Reason, normal force is on the top. My hand is exerting normal force. So that normal force is doing positive work. Force and displacement in the same direction. Yep. So guys, understand that I have done positive work. Think about it now. I have eaten vada pav. I just ate vada pav and came. So when I lift this pen, my vada pav will get digested and my energy will go. So I am doing positive work. I am doing punya. I am doing a good deed. So that's why I am doing positive work in raising the energy. Understood? But if I talk about work done by gravity, what is the work done by gravity? What is the work done by gravity? Think about it carefully. Where is gravity acting? Gravity is acting down. Where is the displacement? Up. Opposite, what will happen? Negative. So that will be minus 10 joules. So you might be like, sir, gravity, why is it doing negative work? Yeah, it's doing a sin, it's doing a pap, it's taking away, sucking away that energy. So when you take it up, it is storing, it's doing, sucking away my energy. It's sucking my vada pav energy and storing it in the form of potential energy. So that's why gravity did negative work. So gravity is a conservative force. So work done by gravity is negative of delta U. Do you see that? Work done by gravity, negative of delta U. And work done by external force is plus delta U. Now you should never have a confusion. Remember this vada pav method. Lifting a pen. Every time you get confused, lift a pen. Delta U positive, work done by me positive. Vada pav, my vada pav did positive work. And gravity sucked away, evil force. It sucked away that energy. So negative work. So this way you will never ever confuse between the signs. Okay. Nikhil Krishna, I just explained when to use one shots. I know I said one shots are dangerous, but I told you how to use one shots just some time back. I hope you were there that time. I'm guessing you joined in a little bit late. I gave a detailed strategy of how to use one shots with the long-term batches. Just one shots, dangerous. One shots plus long-term, yes, that's what you need to do. Next question coming up on your screen. Yes, Zayed, your messages are visible, bacha. Okay, come on, let's get going. Electric field of a charge. We are going to field and potential. Any charge or many charges always create a field around them. That field, due to a point charge, you can see as you go close to the charge, the field is very strong. As you go away from a charge, the field becomes very weak. So at any point, the field due to a charge is given by kq by r square. Q is the charge creating that field and r is the distance. Alright, now you can also write electric field as, you know, the force by the charge, the force acting per unit test charge. So general, okay, actually over here, this should have been plus Q. Maybe I'll just change it over here. Okay, this should have been plus Q, guys. Okay, bada Q. Okay, and this also I should have made it capital Q so that there is no confusion in the symbols. Okay, so force acting per unit test charge. So if I put a test charge over here, unit test charge. So force acting per unit test charge is, you know, the definition, but a more correct definition is when you add limit. So limit Q tends to 0. The reason why you put this limit is this charge should not create its own field and you are just testing it. So an infinitely small charge is enough to test the field due to another charge. So limit Q tends to 0 tells you it's a very small minute charge to test how much field is there. That's it. Great. Cool. So Zad, I'm not sure what exactly your question is. P and Q, the potential energy will be positive or negative. If both charges are positive, Zayad, or both are negative, then it will be positive. If one is positive, one is negative, then it will be negative. Okay, irrespective of the distance. Yes, Hemant, 1 year is enough for BitSat and JEE Mains and Advanced. But if you follow the strategy which I gave on this channel just few days back, just check it out. It's there. Okay. Now, similarly, you have potential. Just like you have potential energy, you also have potential. Potential due to a charge is kq by r, and you can also write potential as potential energy per unit test charge. Again, limit q tends to 0. Okay, very important formula. Energy per unit charge, energy per unit test charge is called as potential. So what this potential and field means is that any charge around it creates a field and creates a potential. So any charge or many charges always create a field and potential around them. The moment you add any charge, then that charge experiences force because of the field, and then that charge with this charge gets energy because of the potential. People get confused between potential and potential energy. See, this is potential energy and this is potential. Okay, now what is the meaning of potential and potential energy? What's the difference? See, when I'm holding this pen over here, this pen has a potential energy with respect to Earth, gravitational potential energy with respect to Earth. But now if I don't have anything, There is nothing here. There is no energy, but there is potential. Aukat. In Hindi, they say aukat. There is a capability of gaining potential energy. There is no energy, but there is capability, aukat, possibility. That hope is potential. There is potential. Yes, this child has potential. But when you actually do that hard work and you actually place some object, then it gets potential energy. Is that difference clear? Is that difference clear? Everyone clear about this? Can we move ahead to the next question and next slide? Okay. Last thing. You would have studied this in work power energy. Force is minus du by dr. Now, force is the negative gradient of potential energy. Now, if you divide this with charge and divide this force also with charge, force by charge is going to give you field, and potential energy by charge is also going to give you potential. So this will become E is minus dV by dr. Yes, Gana Prabhu Vasanta, you need to have potential energy. Potential is there in every one of you. Somebody was asking, who was that? Hemant, I guess. Hemant, is 1 year enough for BITSAT? Yes, bacha, you have that potential to crack BITSAT, JEE Mains and Advance in 1 year also. But you need to get that energy, you need to have that motivation, you need to put in that hard work to actually manifest it and into results. Alright? So that's what it is. E is minus dV by dr, standard formula. Okay, here is the first question coming up on your screen right away. Come on, my warriors. Kukup Sutte, I'm coming on V Biotonic channel this Saturday for formula revision session. Okay? Yep, correct. Let's get moving. Charge of plus 2q and minus q are placed as shown in the figure. The point at which the electric field intensity is 0. Let's see how many of you can do this. Jagan, my teaching experience, how many years? My God, it should be around 12 years. Yeah. So 3 years I was in corporate sector, but there also I used to teach different stuff, little bit higher electronics and instrumentation and all of that. We used to train our customers on different products. Those were big guys, not small kids like you. So I have experience of 3 years of teaching big guys and around 10 years almost for young kids like you. Okay, chalo. Saurabh saying B. Thank you SMS. Thank you for all the love, bacha, from Tamil Nadu. Okay. Shreyas Kapi, my age is a mystery, bacha. Okay, so the correct answer is somewhere on the left of minus q. Now, many of you got it correct. Very good. Proud of you, bachalo. Proud of you. Proud of you. See how to do this. The field is asked. If you are here, the negative charge will pull it. Attractive field. Positive charge will push it. So field will not cancel. Fields will add. So field is not 0 here. On this side, okay, this was due to negative charge, this was due to positive charge. On here, this negative charge will pull with negative force and this positive charge will push it this way. Over here, the negative charge will pull this way, the positive charge will push. Now you might say, sir, here also they cancel, here also they cancel. But think about it clearly over here. You are away from a smaller charge. This negative force will be small no matter what you do. Okay, this positive force will be very big. Why? Because this charge itself is big and you are closer. Negative charge itself is small and you are farther. So they will never ever cancel each other. They can never cancel. But if you are here, the negative charge is closer and the positive charge is far away, but they compensate with their magnitudes. They compensate. Fine, you might be far away from the positive charge, but the charge is bigger. You might be close to the negative charge, but the charge is small. So they cancel each other and therefore the net field will be 0 here. So somewhere on the left of minus q. That's the answer. Clear? Very good. Thank you, Jagan, for all the love from Pondicherry. It's a beautiful town. I love visiting Pondicherry. I have been there at least 2 to 3 times. Beautiful coastal town, especially for relaxing on the weekends with your family or friends. And you get good fish over there. Very nice stays, and especially the architecture, the French architecture, the French restaurants out there, too good. And yeah, I love the French breakfast which they serve. Amazing, like the croissants and all the breads. Amazing food out there. Okay, yes, I have graduated from NIT Vasanta. All right, so charges plus 2q and minus 2q, same scenario, but now the question is the point at which the potential is zero. The point at which the potential is zero. Yeah, Sriji, just when the dropper batch has started, but there is one more batch starting this Monday. You can check out the link in the description box and join it immediately. With immediate effect, please join it. Any further delay will reduce your prospects of getting a good rank. Annalyn, there is no engineering paper which has been conducted today, so there is no point discussing when there is no paper itself. Okay. Ria, I want to visit Jammu, Bacha. I know it's on my list, but I have visited Jammu Kashmir a long time back, but I want to visit again. Ask Wasim sir to call us. He's not calling us. Very bad. Ask Wasim sir to call us. Okay. Yeah. Chalo, let's get going. So guys, the correct answer to this question is somewhere between minus q and plus 2q. Minus q and plus 2q, but closer to minus q. Now, potential is a scalar quantity. Do not forget that. This is scalar. Now, if this is a scalar quantity, you don't have to look at the directions. So, you will be closer to the smaller charge here. And you will be farther, okay, this will be close over here and farther to the positive charge. So, you will see the negativeness and the positiveness will cancel each other. You are close here because the charge is small. You are far from the positive because, the charge is higher. Somebody might say, sir, what about this point over here? Fine, you might be close, okay, and you will be far over here, but you will not get, or you will not see that the potential energy will probably cancel over here, okay. So, understand that the distance will be too large for it to cancel out. So, it will be somewhere between minus q and plus 2q, but closer to minus q. That's the answer, option A. Going to the next one coming up on your screen. Very good. Chalo. Here is the next question. Beautiful question. The question is determine the potential. Determine the potential and the electric field. Determine the potential and the electric field due to this charge array at the center of the cube. At the center of the cube. Let's see. Come on, come on, come on. Let's see how many of you can do this. Jagan, there are no physical classes available in Vedantu. We believe in complete online education as of now, and we feel that students should not waste too much of their time traveling back and forth from the coaching center, and also the distractions that come on their way when you change your city or travel to the coaching center, and a lot of time gets wasted in all the other unforeseen circumstances which come with offline coaching institutes. So that's why we truly believe in online. Plus, the data points that we can capture in online can never ever be done in offline. Like the amount of quizzes, the hotspots, and your attendance, your attentiveness, and all these parameters which are collected by our softwares, which give you reports on how your performance class to class basis is, can never ever be done in an offline institute. Never, it's not possible. Okay, chalo. So, a lot of you are saying 0, but yeah, that's one of the answer. Field will be 0. This will be 0. The reason for that, all the fields will cancel. Vectors. All vectors will cancel each other. But potential, that will not cancel each other. So for that, what I'm going to do is probably I will draw a diagonal. Okay, this is the diagonal. And remember, the charge is at the center. I need this distance. Okay, I need this distance. This distance d from any one charge will be the diagonal by 2. This is the diagonal. Now, what is the diagonal of a cube? The diagonal of a cube is nothing but root 3 times the side. Okay, so the side is B, so root 3 by 2 into B is the distance between them. Now the last thing, the potential at the center will be, there are 8 charges totally, so 8 times the potential due to each charge. The potential due to each charge will be K, which is 1 by 4 pi epsilon naught charge divided by that distance. That distance is this one, root 3b divided by 2. Now 4 and 2 cancels, it will become 2. 8 by 2 is 4, so it will become 4q by root 3 pi epsilon naught b. That's the potential at the center. That's the answer. Very good. Excellent. Be careful, 16 won't be there, 16 will get cancelled out. 16 by 4 will be 4. Okay, yes, that's what the answer is. Okay, very simple, based on scalars and vectors. Vectors will cancel, scalars won't cancel, they will all add up. So do not forget to multiply by 8. There are 8, corners of a cube. That's the reason. Very good. Okay, let's see whether the answer is correct. Yep, it is. Okay, 0 is for the field, this one is for the potential. Excellent. Let's get moving to the next question coming up on your screen now. A uniform electric field, okay, a uniform electric field of 10 Newton Coulomb is existing in the vertically downward direction. The change in the electric potential as one goes up through a height of 50 centimeter. I'm pretty sure many of you are going to make a silly mistake, but I am hoping that you are my warriors and don't do that. Let's see how many of you get the correct answer for this question. There is a uniform electric field which is acting downwards. Okay, so this is our electric field, which is 10 Newton per Coulomb, downward direction. The change in the potential as one goes up, so you are going up by a distance of 50 centimeter, which is nothing but 0.5 meter. Let's see. Please make sure your signs are correct. Make sure your signs are correct. Some of you are saying A, which is minus 5 volt. Some of you are saying B, which is plus 5 volt. This is going to be really interesting. It's simple calculation wise, but the signs and probably some silly mistakes can happen. Remember, I just told you electric field magnitude is delta V by delta R. Okay, just first find the magnitude. Okay, so electric field, well, that's 10. Delta V, I don't know. Delta R, well, that's 0.5. So the magnitude of the potential difference will be 5. Okay, will be 5 volts. But the actual value of delta V, now that's the tricky part. Where does electric field go? Electric field always goes from high potential to the low potential. Remember this. That's how electric field goes. It always goes from high energy to low potential. That means if I go up, my potential should increase because I'm going from low to high. Hence, the answer should be plus 5 volts. That's the answer. Everybody clear about this? Yep. Yeah, Zayed, please let me know what your doubt is. Very good, Swarlina. Very good, Zayed. Finally, oh, Selva made a silly mistake. Janish, very good. Yes, Ria, correcto. Very good, Balaji. Excellent, Surya. Very good, Surya. I think you should be happy now getting some correct answers. Yeah, it is B. Yes, it is B. Very good, Manoj. Very good, Zahir. Yeah. Then the answer will be minus 5 actually. Sir, if the electric field is 10 Newton per Coulomb, which is moving downwards, then the answer will be minus 5. Well, if you go down, then it will be minus. See, if you just use that formula, right? If you just use that formula, okay, so that delta R is here, and you know what is this? This is your electric field, which is how much? 10 Newton per Coulomb. So this over here, your electric field, which is delta V by delta R with a negative sign. This electric field is 10. Okay, delta V, I don't know. Delta R is not 0.5 because actually I am moving here. actual displacement is here. So delta R itself is minus 0.5. Understand that. So that's why when I put minus 0.5 here, therefore delta V comes out to be 10 into 0.5, which is 5 volts. That's the correct mathematical way, but often people get confused with the signs here. So I go by bhavna, I go by feeling over here. First find the magnitude and then think which one is high, which one is low. That will also give the answer. But yes, this is how it is. Yep. Okay, so let's get moving to the next one. All right, cool. So it is actually minus delta V by delta R. Be careful. Delta V by delta R only gives you the magnitude. Yep, cool. Okay, so that's how it is. The electric potential in a 2D region, this is going to be on derivatives, is 3xy plus 4y volts. Find the field in that region. Very interesting question. Now, in order to find the field, don't you guys see, since there are x and y coordinates both, there will be field in x and field in y. So the field in x direction will be minus dv by dx, and that will be minus d by dx of this entire thing, which is 3xy plus 4y. Now only differentiating with respect to x, treating other things as constant, will be minus 3y plus 0, which is just minus 3y. Make sense? This 4y is a constant because you are differentiating with a variable x, so other variables become constant. Similarly, electric field in the y-axis will be minus dv by dy. Rate of change of y coordinate will give you the electric field. Rate of change of potential with y coordinate will give you the electric field in the y direction. So this will be minus d by dy, and the whole function as it is 3xy plus 4y. Treat x as a constant, y as your variable. So this will be minus, okay, 3x plus 4, but with that minus sign outside. Yep, that's the answer. Now therefore the electric field will be minus 3y I cap, because this is in the x direction, and this thing over here minus 3x plus 4 j cap Newton per Coulomb. That's the answer. Everybody understanding this? So use that formula. E is minus dv by dr, but when there are two directions or three directions, differentiate it separately to get the answer. Got it? So here I'll be coming up with a micro course for 12th standard very soon. Okay, yep, very soon, just coming up. Just hold on, just it's around the corner. I'm already in the works of it. Yeah, that's the answer. Okay, next question coming up on your screen. Zayan bhai, shukriya bhai, finally you are attending my classes live and you're feeling so happy. I'm also feeling happy that you're enjoying the live class. Glad to see you bacha live. Very good, Zayed. All right, here is a question. The work done in moving a 2 Coulomb charge from this point to this point in a potential of this many volts is, interesting question. Very good, Swarlina. Come on, let's figure this out. Interesting question. Don't make mistakes in the signs and calculations. Very simple, no need of derivatives. Yep, no need of derivatives. Come on, my warriors. All right, Shreyas Capri. Yo, good to see that you guys are alive. All right. Seeing you guys after a long time makes me feel really good and great. I mean, yeah, I know I was busy with the 2021 students because they had their JEE mains examination, you can blame them for that. All right. So let's see how to do this. Work done in moving the charge from this point to this point. Okay. So come on, think about it. I just told you work done will be delta U, not minus, plus. This is work done means by external force. This is work done by external forces delta U. And what is delta U? Well, since potential is given, can I not say it is charge into potential difference? Charge into potential difference, makes sense? Okay, next step. Potential difference will be V final minus V initial. Alright, this is initial and this is final. So let's do this. What is the value of charge? It is 2. Okay, final. Now final means these are the two values, you are going to put it over here. So final potential is 2 minus 4. That's your final. Minus initial potential. Again substitute the value of x as 0 minus y coordinate as 1. I hope this made sense to you. Now what you need to do is solve this. 2 minus 4 minus 2 and minus plus. So this will be minus 2 plus 1, which is minus 1. Okay, I think there was some mistake or what in the question. Okay, so I think none of the answers are matching. At least this will be nothing but minus 2 joules. Probably the answer needs to be changed. I'll change the answer. Yep, I'll change the answer, guys. Okay, don't worry. Okay, everyone clear about this? Everyone clear about this? Finally, yep, cool. Yep. Oh, Selva also got the same thing and he got confused. Don't worry, I will change the answers over here. I'll change the answers in the PDF. In the PDF. Do you know where do you guys get the PDF of this session? Yeah, you guys get the PDF of this session. You know where? In the description box. But that will come late. There is an early way, quick way. What's the early way of getting the PDF? That's Telegram channel. There's also a link in the description box for joining our Telegram channel. Just join it so that you get the PDF of the session. Don't worry, I'll change this answer out here. Okay, yeah, very good. Okay, don't worry about this, that was wrong. Okay, chalo. Here is the next question coming up on your screen. Electric field lines and equipotential lines. Electric field lines, nothing but give you the direction of the field. They give you the direction of the field. And field never intersects. They never intersect each other. Equipotential lines are those lines where the potentials are same. And remember, always the field line travels from high potential to low potential. That's the always rule, the rule. And one last thing, a field line and potential line are always perpendicular to each other. Always keep this in mind. These are some simple rules which you should know. And where the density is more, the field is also proportional to it. More the dense the field lines are, higher the intensity of the field. Less the field, less the density. They always start from positive charge and they end at a negative charge. More the charge, more the field. Less the charge, less the field. Also you can see the field lines are perpendicular and they will always go from high potential to the low potential. You can see all these green lines are equipotential lines. Everywhere the potential will be same. And you can see the fields are directed outwards for positive charge. If it was negative, it will be inwards. These are some simple rules that you should know. Okay, clear? Shall we solve some questions on this? Shall we solve some questions on this? All right. Yep. Okay, chalo, koi baat nahi. Okay, let's get moving to the questions coming up on your screen. Okay, chalo, let's solve this. Here is the question coming up on your screen right now. Okay, oops, yeah. The figure shows the electric field lines around 3-point charges A, B and C. Which charge has the largest magnitude? Which charge has the largest magnitude? Come on, my warriors, figure this out. Which charge has the largest magnitude? Come on, my warriors, think about it. The charge which has the largest magnitude, the field lines are given, very easy. Abhirami Kutti, come on, start answering. Probably I will take your name. Hello, by the way. Yes, last question, what doubt, bacha? Probably can leave it after the session is over also. Okay, B and C, some of you are confused. The correct answer is D. C charge has the highest amount of charge. C has more lines. Count the number of lines. 1, 2, 3, 4, 5, 6, 7. 7 lines here. From B, 1, 2, 3, 4, 5, 6, 7. 7 lines here. From C, obviously it's more than 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 lines. Obviously C has the highest charge. But if somebody asked you between B and A, both of them will have equal charge. Okay, got it? Chalo. Let's get moving to the next one. Janish, probably you made a mistake, bacha. Okay, you just do it again, you will understand it. Just watch the replay, you will get it. Okay, just probably, I think, some sign mistake or something. Vatsal, I doubt you should take a drop because there is a good chance you can do really well, Vatsal, in advance. So please focus on advance. If you don't clear advance, then you take a drop. Okay, 97.8 is not bad, not great percentile. Next question coming up on your screen. Okay, chalo. A metallic solid sphere is placed in a uniform electric field. The lines of force, lines of force follow the path shown in the figure. Only one of the lines is correct. One of the lines is correct. Most of you are saying 1. Hi Raja Raman, come on. Shouldn't we consider the imaginary lines felt? Zion, yes, you should only consider the lines given. It's a depiction of how the field will be. Obviously, you can never draw all the field lines because the total number of field lines coming out of a charge will be infinite. But it's just showing you how many lines are coming, just to give a sense of the magnitude of the charge and the field. Okay, so yes, the correct answer for this is only 4. And be careful, this word is very important, metallic. This is a conductor. Now in a conductor, keep this in mind, the electric field lines are always going to be perpendicular. That's a standard property. Doesn't matter what the shape is, the field lines always are perpendicular to the surface, and inside a conductor the field is always 0. This is very, very important property for a conductor. Okay, got it? So no, it's not 3, 2 or 1. 3 is passing through the conductor. 2 is also passing through the conductor or around it, which is not correct. Inside the conductor the field should be 0 and they are not even perpendicular, guys, at the surface. So it's wrong. Next question coming up on your screen now. So real Kannadigas, aisa hai. The thing is, whenever you have a conductor, right? If this is the surface of a conductor, the field always, remember, the charges are always on the surface. The field is always perpendicular to the surface. Inside the conductor, the field is 0. There is no component of field in the surface's direction. That's a standard property of a conductor. Okay, fine. That's the property you should know. Inside the field is 0 because what happens, no matter what the shape is, because the charges always reside on the surface, the net field will cancel out. The fields will cancel. Only the fields are there outside. That's it. Okay, chalo. Let's get going. So I'm expecting the class to end by 8:30 or 8:40. Yep. That's why I started it early. Okay, so around 2 hours, I guess. Yeah, 2 hours, 10 minutes or something. The figure shows the electric lines of force from a charged body. If the field at A and B are E and EB, potential is VA and VB, then the potentials are, and the comparisons are, come on. Preeti, there was no JEE paper only, so there is no point of discussion. Okay, so there was no engineering paper which happened. So that's the reason there is no discussion happening today. Alright, so let's see how many of you can get this. First of all, don't you see the density is higher over here? If the density is higher, then the field also should be more. The field also should be more. Okay, so A has more field. So either this or this. One of them will be correct. Second part. Field always goes from high potential to the low potential. That means A's potential should be higher than B. So there is only one option that is correct, then that is this, option B. D is wrong. Yep. Yeah. D says VA is less, VA is not less, VA is in fact more. Hence option B is correct. Okay, yep, very good. Next question, which of the following lines of force is uniform? This is probably the most easiest question of today. Which of the following lines is the uniform field force? Come on, come on. Okay, so triple IT, there are a lot of colleges, but the good ones are in Hyderabad, Bangalore. Yeah, these are the good ones. All right, it's option A. Yeah, E's minus Vy, or also you can use Jebin Jacob, but this is very obvious. You can remember it as a rule. It always goes from high to low. That makes it easier than minus dV by dr. Correct answer is obviously A. The field lines are spaced equally. Here, understand, all right, what you can see over here, the field lines are not spaced equally. This is small, this is more, suddenly this is something else. But here, this is equal, this is equal, this is equal. So this is why this is uniform. Obviously, this is not uniform. Direction is not constant. Magnitude is also probably changing. So this is not uniform. Thank you, Ankit. All right. Oh my God, somebody is saying my eyes are small. Is it? Oops. Yeah, it happens. The reason why my eyes are small is because there are a lot of lights which are there. Probably you don't know how many lights are there right now. For you guys, it looks very simple that, okay, there is a board and that's it, sir is here. There is one light here. There's one light there. There's one light here. There's one light there. There's another light here. Okay, so there are so many lights out here. So that's why it's a natural response to so many lights. That's why probably my eyes look a little bit closed. I don't know. Okay, chalo. Definitely. Thank you, Vidya, for all your concern. And I'll definitely take your advice. Definitely. All right. Yep. Thank you so much, bacha log. You guys are so mindful and so concerned. Okay. Chalo, let's get going. Here is a figure which shows equipotential lines comparing between point A and B. Pick up the best possible statement on the field. The field is more or less, where is it directed? This is also simple. Just check the directions, check which one is more, check which one is less. Potential wise, you will easily get the directions and the magnitudes. Come on. Can you find the speed of light experimentally? My God. Yeah, what I'm going to do is I'm going to start the watch and then I'm going to turn on my flashlight and I'm going to run and I'm going to calculate my distance and then I'm going to look at my watch and I'll be like, yeah, oh light, oh, it's still coming. I'll wait for the light to come and then that's how I'm going to measure the speed of light. Okay, Ankit, if that's how you want me to measure the speed of light. But yeah, there are beautiful videos on how to measure the speed of light and how you cannot actually measure the true speed of light. Beautiful videos are there on that on YouTube as well. Okay, chalo, let's get going. The correct answer, guys, by the way, this is 5 volt. This is low voltage. This is 15, 25. That means this is high voltage. That means the field will be always from high to low. That's it. So the electric field has a greater magnitude at point A and it is directed towards the left. Well, see here the potential changes very quickly. Potential, see, field is definitely directed towards the left. Left, left. This is wrong, this is wrong. Now the electric field is more at B or at A. The answer for that comes via this. Del V by del R. Here the distances are small. That means denominator is small. That means this is large. That's why the field is more here. The potential drops are same, but it happens very quickly. So that's why the field is more. Understood? Clear? Let's get moving to the next one coming up on your screen. Hi, Raji Pratap Jadhav. Wow, what names you guys have. And very nice. Chalo. That's option A, guys. Moving on to the next and the last few things coming up on this in this chapter. Okay. Yesterday's paper was not difficult, it was easy. What is del V? Del V is potential difference, Jagdish Kalkuri. I think you were late to the lecture. Just rewind back a little bit. Potential difference, rate of change of potential with respect to distance. That's del V by del bar. Hi Sai Srinivas, welcome aboard. Okay. Now, field and potential due to a dipole. First of all, what's a dipole? A dipole is nothing but equal positive and negative charges together. It's called as a dipole. Now, there is something called as a dipole moment. Dipole moment is charge into length, where Q is the charge and L is the length of the dipole. Many books, they will do this. This is minus Q, this is plus Q. This distance, they will write it as 2L. Why do you want to write it as 2L? Just write it as length, right? Reminds me of that famous TikToker and Instagrammer, Cabby Lame. Like why? Why do you want to write it as 2L? Just write it as L, please. Okay? So just put it as L. Why do you want to write 2L? It creates a lot of confusion. Okay. So P, which is the dipole moment, is charged into the distance between the two things. It's a vector quantity. It's a vector quantity. Thank you, Dhruv Bacha. And it is always from the negative to the positive side. Remember, it's a vector, and that vector's direction is always from minus to plus. Yeah, great. Having said that, when you have a dipole, actually this should have been minus, guys. Okay, just 1 second. This is minus, this is plus. Okay, now the dipole moment is over here from minus to plus. If you are at any point around the dipole and this distance is much larger than the distance between these two charges, that means this dipole is very small and you are very far, then the electric field at that point can be easily calculated, and it comes via the vector addition of fields due to both of them. The negative charge will give a pulling field here, the positive charge will give a repulsive field like this. The resultant will be, let's say, E. This E has two components. One component here, which is generally called ER, and the other component like this. Okay, this is E theta. Generally, this is what it is denoted by. That field in vector form is given like this: P by 4 pi epsilon naught R cube. Notice the cube. Be careful. And the two components are 2 cos theta R hat. So this component, this is R hat, by the way. R hat is this way. And sine theta, okay, theta hat. Theta hat is always the perpendicular component. Remember, any vector form, whenever you write R hat, it is in the direction of the vector, position vector. Theta hat is the perpendicular vector. That's all it is. Okay. Now, what you need to understand is that even if you don't remember this formula, it is okay. It's fine not remembering this formula. This is the more important formula, the magnitude, which is the resultant of both of them. See, the resultant is P by 4 pi epsilon naught R cube. R is the distance where you are from the dipole, which is very large. Okay, to root of 3 cos square theta plus 1. That's what you need to remember. And I'll tell you what, this angle, which is there, theta, can be easily written down as tan theta. Sorry, my bad. I cannot put theta because theta has been used over here. So let me make this as alpha. So tan of alpha will be tan theta by 2. This is the formula. If you remember this, it's easy. So you know the angle, you can easily resolve in case the question demands you to find the individual components. But generally I have not seen a question like that. Okay, but just in case. And you should just know the magnitude and just the angle which the resultant field makes with the position vector. This, remember, is the position. This is the position vector. Keep this in mind. All right, clear? Okay. Now, if this much is done, last thing that I want to talk about is the potential. The potential at any point. The potential at any point. This formula is very simple, guys. It's already written over here. P cos theta by 4 pi epsilon naught R square. Notice the R square here. In field you have R cube, in potential you have R square. So that's the formula for the potential at any point. So if theta is 90, it makes sense that anywhere on the perpendicular bisector, you are equally placed from the positive and the negative charge. So because you are equally placed from the positive and negative charge, the potentials will add up to be 0. So that's why when theta is 90, you will see that the potential is 0. Okay, so that's how this field and potential works. Raj, I'll tell you what, do one thing. Just do one small favor. See, on our channel, you know how to go to playlists. Just do me one small favor. Okay, just go to playlist and go down and go to JEE Physics. In that, go down a little bit, you will see electrostatics, bacha. Just click on this electrostatics. Okay, now what you do, go a little bit down, you will see detailed classes. On dipole, I have conducted almost 1.5 hour class. So click on this, and you will see this detailed class of mine, okay, where I have derived so many things, okay, due to dipoles. This is me, long time back, okay, talking more about dipoles. So you can check this out, check this lecture out in detail, okay. Okay, is that fine, bacha? That's what you need to do. Okay, let me just close myself from this. Yep. Okay, detailed class, but this is more like a revision class. Okay, Raj. Okay, chalo. Let's solve some questions on dipole. First question. There is a point Q which lies on the perpendicular bisector of an electrical dipole, moment P. If the distance of the Q from the dipole is R, much larger than the size of the dipole, then the field at that point is proportional to which power? Okay, come on, my warriors. Come on. Let's see how many of you can do this. Okay, so there is a dipole moment, that's P, and on the perpendicular bisector you have point Q, this is R. What is the field proportional to? I just gave the formula for field, right? What is the formula? It was 1/4 pi epsilon naught. You had dipole moment and you had R cube and you had 3 cos square theta plus 1. Now this is theta is nothing but 90. Cos 90, theta is 90. Cos 90, 0. Correct? So you're just going to get this as P by 4 pi epsilon naught R cube. So what is the field proportional to? Is it not inversely proportional to R cube or just directly proportional to R raised to minus 3? That's the answer. As simple as that. Understood? Oh? Shall we go ahead? Okay. So keep this in mind. Chalo. Yes. If the question was potential, then the answer will be option A. Okay. Yes. Definitely, Zayan. I'm here on YouTube or even on the regular paid platform only with the one motive, and that is your success and your growth and your good ranks. That's it. Okay, chalo. Next question coming up on your screen. If EA be the electric field strength of a short dipole at a point its axial line, 1 second, I think some framing is wrong. If E be the electric field strength of a short dipole at a point and EE is the electric field on the equatorial line, okay, at the same distance, then which one is how many times of the other one? Come on. Glad to know that, Dhruv Nanvi. Glad to know that. Yep. Oh, Ankit, thank you for informing, bacha. I will definitely have a look into it and I will analyze and I will see what we can do about it as well. Okay. So, see guys, if you have a dipole and if you are over here and if you are over here. Now, EA be the electric field strength of a short dipole at a point on its axis. Okay, this is the axis. This is the equator. On the axis, it's EA. On the equator, it is EE. Now, if you think carefully, you will realize that on the axis, theta is 0. Whereas, at the equator, the theta is 90 degrees. Now, if you remember, in that formula, you had P by 4 by epsilon naught R cube root 3 cos square theta plus 1. Now, quickly think, if I ask you EE by EA for the same distance, all these numbers will get cancelled. So, put theta as 90, cos 90, 0, 0 plus 1, 1, 1's root is 1. And put theta as 0 degrees for the actual position. So for 0 degrees, cos 0 is 1. 3 plus 1, 4. Root of 4, 2. So hence, EA is 2EE. EA is 2EE. That means this should be the answer. Yep, easy peasy. No, the final answer is not D. Be careful. It is B. It's B. Raj Pratap, I have little bit of cough, but I am fine otherwise. Okay. Yeah. The answer is B. Oops. Where is the answer gone? Oh, okay. It looks like the answer slide is only missing. The correct answer is B. Okay. I'm telling you now. Okay. Oh my God. Vasudharini Vijay, you are very late, bacha. Please watch the replay. Next question coming up on your screen. Interesting question. A lot of you might make some silly mistake. Oh. JEE Mains has simple and advanced question, difficult questions, Hemant. But remember, this is one shot, bacha. In one shot, I cannot, give very difficult questions. If you want difficult questions, it's there in the playlist. JEE Mains and Advanced series for Pathfinder. 12th standard students, it's all there. Detailed classes. Dipole is a separate class. Field is a separate class. Force is a separate class. It's all there. You can check it out. Plus, advanced level classes are also there for every chapter. Okay, you will see that. Yeah. Okay, come on, my warriors, figure this out. Yeah. So, the charges are given at different points. Let me first draw the diagram. That will be better. Okay, so these are the x and the y axis, I suppose. Q1 plus 6 nanocoulomb at y is plus 3. Okay, so that means here you have plus 6 nanocoulomb and this distance is 3 centimeter. Okay, then you also have another charge which is minus 6 at minus 3. So this is also 3 centimeters. This is minus 6 nanocoulomb. And you have another test charge 2 nanocoulomb at 4 centimeters. So that is 2 nanocoulomb and this is 4 centimeters. Okay. Now it's obvious that this 6 on this 2 and this minus 6 on this 2 will exert same magnitude of force. Now you can quickly see that this side length will be 5 centimeter, 3, 4, 5. This side length 3, 4, 5. This is also 5 centimeter. That's why the magnitudes will be same. Plus and plus repel. So you are going to see a force acting this way. Okay, let's say I call it F. Okay. Minus and plus attract. So you are going to see a force acting this way. Fair enough? Okay. Now, how will the resultant be? Isn't it obvious? By symmetry, you're going to see that the resultant force should be this direction. Net force will be this direction. Okay. Now the last part, what are these angles? Wait a minute, this is 3, 4, 5 triangle. This is something which I already know. This angle is 37 degrees, right? 3, 4, 5. I've told you 53, 5, 3. This is 53. This is 37. If this is 37, this is 37. Then definitely this is 53 degrees. So is this angle 53 degrees. Fair enough? Okay. Now comes the last part. What is the net force? Think. These two forces, each force of them will have two components. Downward, horizontal. This force, downward, horizontal. What will happen? The horizontal forces will cancel each other. The components are going to cancel. Only the vertical components will add up. Make sense? So what's the vertical component? F cos 53. So it will be F cos 53. But there are two components like that. So F cos 53 twice. Cool? Let's get moving. Let's get moving and see what happens. What is the value of this force alone? What is the value of this force alone? That value will be K QQ. Okay, so K QQ. I'll just put it as Q1 Q2. Okay, Q1 Q2 maybe, I don't know, divided by R square. Okay, into 2 because it's coming 2 times into cos 53. What is cos 53? Come on guys, this is 53 degrees. Cos 53, 3 by 5. So this is 3 by 5. That's it. Now you just substitute all the values and you'll get the answer. Okay, so K is 9 into 10 to the power 9. Okay, charge 1 is 6 nano, that means 6 into 10 to the power minus 9. Charge 2 is 2 nano, that means 2 into 10 to the power minus 9 into 2 into 3. Okay, the whole thing divided by R. What is R? 5 centimeters. So it is 5 into 10 to the power minus 2 whole square into this 5. Just do the math, you will see one of the answers. But obviously you can eliminate these two because they are in the plus j. Answer should be in the minus j only. It will be one of them. It will be one of them. I hope this is clear. I hope this is clear. Everybody clear about this? This is based on vectors, trigonometry, forces, Newton's laws, and obviously electrostatics at the end. And just substitution and you'll get it. Okay, cool. That's something which you can do, and I guess the answer should come out to be, oops. Oh, looks like the slides are misplaced. Okay, the slide which I was expecting the answer for is over here. Don't worry guys, I'm going to change the PDF later on. Yeah, the answer is A. Okay, cool. Chalo. Let's get moving. Zion, drawing the rough diagram, making some mistakes. It happens. Probably sit coolly, and plus this is a live lecture, so there is obviously a little bit of speed required. But when you sit at home, be patient. Do not be in a hurry. Whenever you solve problems, don't put timer. A lot of people say time yourself. No, never time yourself unless you're writing a test. Okay, or when you're revising towards the end. Okay, thank you Vedant Bacha. Okay, next question coming up on your screen, but before that, last part. Dipole in a field. We just saw one thing, that whenever you have an electrical dipole, okay, that dipole creates a field around it. And there is some potential at every point. But what happens if you place this dipole only in somebody else's field? This is somebody else's external field. What will happen then? When you place this dipole in somebody else's field, then this charges will experience forces, and because of these forces, okay, you will see a torque acting on it, and that torque is P cross E. Oops, yes, P cross E, correct. This is the external field, this is the dipole moment. So that's the torque acting on a dipole placed in somebody else's field, which is also Pe sine theta, the angle between dipole moment and the electric field, that is theta. So you can easily see when angle is 0, there is no torque. Even when the angle is 180 degrees, there is no torque. So the torque is 0 when, you know, theta is 0 or 180. 0 means P and E are in the same direction, 180 means they are in the opposite directions. Okay, net force is always 0, very important. Reason, because think about it guys, dipole means equal amounts of charges. So whatever force acts on the negative charge and on the positive charge should be equal, right? Should be equal, so the net force will cancel. And remember, this external field is uniform. If it is uniform, that means the field strength here as well as here will be the same. So that's why they will cancel each other. Last thing, whenever you see there is a torque and you know there are some points, you know, where it will have certain energy because of that field, you can also associate some potential energy with that dipole. Now see guys, when the dipole is in the direction of the field, okay, the torque is 0. But when you tilt it, there is some torque acting on that dipole, which will bring it back to its original position. This action of bringing the dipole back in the direction of the field gives me the sense as if it is behaving like a spring. Remember, when you rotate something and it comes back, it gives you the sensation, oh, it's a spring-like force. And a spring-like force should also have an energy associated with it, which is potential energy. So when you rotate this dipole, you will also see it has some energy associated with it, which is the potential energy of that dipole due to the external field. And the formula is minus P dot. This is a dot product. Keep this in mind. This is dot product. So actual magnitude will be minus Pe cos theta. Is that clear? Yes. Keep this in mind. Very good. So with this, let's start solving some questions. You'll get an idea of this. Okay, observe carefully the field lines and observe carefully this dipole, negative, positive. You can see the dipole moment here. The question is, will the dipole experience any force or will it not experience force? And if it experiences, where does it experience? That's the question. These are the field lines. Observe the field lines very carefully. Thank you, Anushka. Yes, sir, Rajay Pratap Jadhav. Like I said, I have little bit of cough and I had little bit of cold. Actually, few days back, I was not in town. I was in a jungle. We had gone for a jungle safari to find some wild animals. We got hold of some nice shots of wild elephants, bisons, some reptiles, and yeah, deer, of course, and yeah, langurs and a lot of different kinds of monkeys and all of that. Unfortunately, we couldn't see the tiger. So during that ride, we went early morning, almost like 6 o'clock, 7 o'clock. It was like crazily cold and I was not with my jacket and all of that. And probably that's where I fell a little bit of sick. Okay, chalo. Avinash, very good. Only 4 mistakes. That's a good accuracy rate, bacha. B and C are the same, is it? Oops. Okay, then B and C should not be the answer. Oh, all right. I think one of them should have been right or something. Okay, probably this answer. Okay, this should have been right, probably. Yeah. Okay, so this will be wrong then. Okay, now the reason why this option is correct is because, see, this is a non-uniform field. A lot of people think the force should be 0, but the answer is not 0. Keep this in mind. This is non-uniform. In fact, it is stronger here and the field is weaker over here because the lines are away. Here the lines are close. So hence the force on the negative charge, will be higher, and force on the negative charge will be this way. The force on the positive charge will be slightly lower. That's why when you account for the total force, the total force will be towards the left side. Is that now clear? Yep. Is that now clear? I'm not afraid of it so much because we were in a jeep. It was an open jeep, but generally these animals do not attack these safari vehicles. That's fine. I mean, like, yeah, I will definitely upload the videos on Instagram very soon of the elephant attacking us. It is really cool. Okay, yeah, Akshay, it is obviously useful for NEET because the syllabus is the same. All right, thank you, Siva creators. Okay, next question coming up. Bhukya, you want advance update? I will definitely conduct a session for advance. Just give us some time. I'll conduct, okay? Because long time, it's been a long time since we conducted classes for 12th and 11th. It's almost like a week. So I know 11th and 12th standard students were waiting for us. So that's why it's important that we conduct few classes. And again, I'll come back to advance as well. Don't worry. Hello, Anjali. Are you Anjali from the batch I was teaching long time back? I'm not sure. Okay. So let's get moving to the next question. Zion, it should be easy, bacha. I'm guessing NEET will be easy. Don't worry. Electric field is this much on an electric dipole at 45 degrees and the dipole moment is this much. What is the potential energy of the electrical dipole? Interesting. Come on, my warriors. Figure this out. The question is, what is the electrical energy? Electrical energy, I just told you. It's minus P dot E, which is minus PE cos theta. Do I know the value of P? Yes, I do. It is given 10 to the power minus 29. Do I know the value of E? Yes, I know. It is 10 to the power 3. Do I know the value of theta? Yes, it is cos 45. Cos 45, do not forget, it is 1 by root 2. Now 1 by root 2, if you do the math, it's a standard value. You should know that. It's 0.707, but I will take it as 0.7, it's fine, into 10 to the power minus 29 and 10 to the power 3. That's going to make it 10 to the power minus 26. So does any answer match? Yes, I think this one. Yep, just take it over here. You can write it as 7 into 10 to the power minus 27. Yep. Okay. Okay. Oh, okay, Anjali, you're new. Okay, I thought you are one of my students which I was teaching in offline a few years back. So She's also right now in 12th. So I thought you are in class 12th, that offline student. All right, cool. Nice to meet you, Kavya. Hello, Bachalog. Welcome. Okay, chalo, let's get moving to the next question coming up on your screen, and that's -7. Yes, like we thought about. A neutral water molecule, H2O. Everybody knows this from chemistry. H2O is a polar molecule. It's neutral because the total charge is 0, obviously. But it has a dipole moment of this much. The molecule is placed in an electric field of so much. The maximum torque the field can exert on that molecule. Very good. Let's see. Come on, my warriors. Figure this out. Yes, Zahid, I can see you, bacha. Come on, figure this out. Thank you, Nivi, for all the love from Tamil Nadu, bachalo. Okay, think carefully. Okay, so you have the water molecule's dipole, and the question says maximum torque. Torque is m cross b, that means mb sine theta. If you want to maximize this torque, that means maximum value of sine theta, which is 1, that happens when theta is 90 degrees. So that happens when dipole and field are perpendicular to each other. Cool. So let's just substitute the values. M, dipole moment, that's 6 into 10 to the power minus 30 Coulomb meter. It's not centimeter, don't get confused. Okay, into magnetic field, it's 1.5 into 10 to the power 4 into 1, of course. So 6 into 1.5, 9. So that's going to be 9 into 10 to the power minus 26. Yep, that's answer C. How many of you got it? C? Oh, a lot of you are saying C. Very good. Oh my God, somebody wants to be an ophthalmologist. That's very cool. In fact, I had just conducted a session with one of my friend and a very popular doctor in Hyderabad. He's working in LV Prasad Eye Institute. You can check it out, how to protect your eyes from online classes and the myths around watching computer and wearing those blue filter goggles and all those shades. So there was a session which I conducted a few months or probably a few weeks back. You can check it out, and he might probably be an inspiration to all of you and also help you with how to protect actually your eyes from different harmful things around you. Now, one important thing that I would like to tell you is that Vedantu cares for you. No matter where you are, no matter how you are, no matter at which position you are. A lot of coaching institutes only focus on toppers. They do not care about the students who do not perform well. Vedantu is one institute you will see which actually genuinely cares about everyone. Now, when I say this, I mean it. Now, some of you might say that, oh, sir, is just marketing Vedantu. No, guys, we are actually promising you by VIP. What is this VIP? We conduct a test before you join Vedantu, and we also see how you are towards the end of the course. If there is an improvement, no matter which student you are, which batch you are in, if there is an improvement, good. If there is no improvement, you are going down, we return back your fees, and that's Vedantu improvement promise. So no other coaching institute offline or offline will do this for you. And you have batches which have not only the regular long-term batches, you have regular long-term batches starting, and you also have other things associated which you should get, like tests, assignments, and also Tattva booklet. The hard copy will be couriered to you. Not just that, you will get parent-teacher meetings. You will have strategy sessions. You will have guidance session. You will have mentors. You will have so many different things happening apart from the regular classes, which will help you develop yourself as a personality, and it will help you stay motivated. And you will obviously have teachers like me. Okay, and look at this, you have separate batches for Hindi as well as English. You also have Shreyas sir's Capto's micro courses. You have my micro courses and other teachers' micro courses for free. Not just that, KVPY, Olympiads, CBSE, it all is included in this platform of Vedantu. You don't have to pay anything extra. It has one roof for everything. You don't have to Yeah, dwell in different homes. Oh, I want this mountain view, I need to go to that home. Oh, I want very nice interiors, I need to go to that home. Oh, I want AC, I need to go to that home. No, this is one house, this is one home where you get everything, a nice view, a nice interior, AC, whatever you want. So I hope you get the analog. Okay, yeah. So the course price is barely 3,000 per month if you take the light version. Classic version, the only additional thing you get is the doubt solving, which many people opt for. Many people go for this because they want doubt solving after the class, and you can chat with our doubt experts from morning till night, unlimited doubts, no restrictions at all, and you just have to download the app. And if you want personal mentorship, you go for the plus version. The batches are starting this September 6th. Now that means you need to join and make up your mind very quickly, because if you lose this, then again the next batch will start after more 2 weeks. That will obviously reduce your time which you are spending at Vedantu, which I would definitely not recommend. I would want you guys to join the platform immediately. I would want you guys to see my micro courses, other teachers courses, the long-term batches, the doubt solving, the booklets, everything at your doorstep. Don't have to travel anywhere, and that too in English medium. What more you want? And for these prices, now you might say, sir, can I pay the whole amount? Yes, you can pay the whole amount. You can also pay the EMI. You can opt for the EMI option, and you roughly have this much amount to pay per month. That's also valid. That's how it is. Yes, NEET के लिए भी है अंशुल ये courses. Yes, NEET के लिए भी है. Bhumi, advanced series will be starting on this channel very soon. Janish, I'm going to drink coffee again in front of you very soon, but otherwise I'm going to drink coffee very regularly. Anyways, my throat is bad today, so I think I need a coffee again. Okay. Yeah, school is giving too much of homework. Offload it, Ankit, to your younger brother or sister. Call your younger brother or sister, like, hey, fill up my journal. This is what many people do, huh? Smart trick which you can do. Donkey work it is. Why do you want to do donkey work? Yeah, please offload it. Okay. How to overcome failures in exam? Well, it's very difficult to actually, overcome any kind of failure in any aspect of life. One thing you should understand, that a lot of people just look at success as not having any failures, and it's very easy, and probably it's luck, or probably everything worked in his favor and things like that. But understand, nothing is like that. I mean, even if you see a topper, even if you forget toppers, even if you see a all India rank 1000 guy, it's not an easy journey for him. He has encountered many failures, he has encountered many hardships. You don't even know. Probably you have a home, probably you have a coaching institute, probably you have money which you can afford to buy books and all of that. There's so many students who cannot do that. So you should feel privileged that you have so many things. Don't look at the negatives within you. Try to look at what you have. Don't think about the things you did not do or you did not achieve. Rather, think about how privileged you are and what you can do better. And always have that goal, ambition in your mind, like, oh, I want to get into IIT Bombay, or I want to get into IIT Kanpur, I want to get into IIT Madras, I want to get into this branch, I want to do this. When you have that craze for doing something, you can easily overlook these failures and you will definitely do well. All right, chalo. So that's it from my side. Yes, Zain, the class is over. Should you go to school daily? I would recommend keep bare minimum attendance. My next class is tomorrow at probably 7:30. That's for the 11th standard, but even a 12th standard kid can attend it. That's a revision class, one short class for 1D kinematics. And our class will be on Saturday, again at 7:30, revision on Gauss's law. So guys, if you enjoyed the video, please do not forget to smash the like button. And if you are new to the channel, do not forget to hit the subscribe button as well. That's it from my side. Thank you guys for all the love, all your support, and love you guys. Take care, stay safe. See you again on Saturday as well as tomorrow. Hasta la vista.